Hey everybody, welcome back to Mr. A's geometry course. Today we are covering section 3.2, which is all about the angle pairs that are created by parallel lines and transversals. Let's get into it. In 3.1 we learned all about these angle pairs that are created by transversals, like corresponding angles or alternate exterior angles. In 3.2 we're going to learn that when parallel lines are intersected by transversals, there are these geometric theorems that we need to memorize for each angle pair, meaning things like alternate interior angles are going to have specific math facts that apply. But remember, it's important to know this is only when the lines being intersected are parallel to each other. Remember, there were 4 angle pairs that we learned about, so we have 4 theorems now that we need to memorize when parallel lines are intersected. The first is the corresponding angles theorem. If parallel lines, again, have to be parallel, are intersected by a transversal, then corresponding angles are congruent to each other. Therefore, we'll look at our figure here. If line AB is parallel to line CD, again, we keep saying this, the only time these theorems are true is when our lines are parallel to each other. So I know these lines are parallel, they have the same amount of arrows on them. If they're parallel, then angle AER, which is this angle right here, would be congruent to angle CFE, which is this angle here. So those are corresponding angles, but because these lines are parallel, I now know these angles have to be equal in measure. So if AER here was 100 degrees, CFE would also have to be 100 degrees. Our first example here is asking us to identify the angle that corresponds with the 123 degree angle in here, which is right here. Remember, corresponding angles are in matching positions. So the angle that matches that 123 would be this angle 1 up top. And in 3.1, all we learned is that those were corresponding angles. But now we're learning this theorem that applies when our lines are parallel, and line A is parallel to line B here. It might be hard for you to see on screen, but there's little red arrows here, matching amount of arrows telling me that these lines are parallel. Because they're parallel, these corresponding angles must be congruent to each other. Again, make sure that's clear. If we didn't know these lines were parallel, we would not be able to know how many degrees angle 1 is in this example. But because they are parallel, I know that the measure of angle 1 is also 123 degrees. We will, of course, have to apply a specific amount of algebra to these theorems. So I can first identify, I have parallel lines here because I have matching amount of arrows on each line. Next, I can identify my angle pair. Both of these angles are in the top left of their intersection, therefore they are corresponding angles. And because they're corresponding on parallel lines, we've learned just now that these must be congruent to each other. So that 13x plus 2 must equal the -4 plus 14x. There are a few different ways you could do this algebra. I like getting all my variables to one side first, and I like moving the smallest amount of x's. So I would subtract 13x from both sides to start this problem. That would leave me with the 2 on the left equal to -4 plus just a single x on the right. I can then add 4 to both sides of the equal sign to get x equals 6. Let's make sure that we're always thorough students in answering the question that's being asked. In this case, we're just solving for x. So we're done here. X is 6. Our second theorem we have to memorize here is the alternate interior angles theorem that tells us if parallel lines are intersected by a transversal, then alternate interior angles are congruent to each other. These are also going to be equal in measure. So we look at our visual. I can see that line AB here is parallel to line CD. They have matching amount of arrows on them. If that's true, then our alternate interior angles will be congruent to each other. So AEF, which is right here, would be congruent to EFD, which is right here, because they're alternate interior angles on parallel lines. They must be equal in measure. We have here the same visual figure here as we had with our corresponding angles theorem, where we're given 123 degrees at the top left of this intersection down here. We're being asked now to find the angle that is alternate interior pair with the 123 and then determine the measure of that angle. So remember, alternate interior angles have to be between your parallel lines. So between A and B and on opposite sides of the transversal. So I jump to the other side of the transversal and I jump to the other intersection, and that would be angle 3. And we're learning today that because A and B here, these lines are parallel to each other, that these alternate interior angles must be equal in measure. Therefore, angle 3 is 123 degrees. Here's our example that is testing us with some algebra added into this. Notice here, this example tells us in the directions that we have parallel lines. Don't forget that's your symbol for parallel lines, those vertical bars there. Because our figure doesn't show us that they're parallel. I don't have matching amount of arrows. It looks like they're parallel, but I need that proof to apply these theorems. If that wasn't known, it would not be possible for us to solve for the value of x. But because we know they're parallel, our theorems apply, we can do our work there. These angles are in the position of alternate interior angles. They're between lines A and B, they're on opposite sides of our transversal, and again, we're learning that these angles are congruent to each other. So things that are congruent, we set equal to each other to solve. So I got 5x minus 54 equal to, we have 3x plus 16. And from there, we're doing the appropriate algebra to solve. I like moving my smallest x's, so I would subtract 3x from both sides. It would leave me with 2x minus 54 on the left, equal to 16 on the right. To get that 2x alone, I can add 54 to both sides. And that would give me 2x equals 70, and then I can divide both sides by 2 to get x equals 35. Again, the question was just asking me to solve for x, so that's my answer in this example. Next, we have our consecutive interior angles theorem. It says if parallel lines are intersected by a transversal, then consecutive interior angles are supplementary. This is the one that students tend to struggle with the most, both visually and mathematically, remembering about consecutive interior angles. So on parallel lines, those angles are going to be supplementary. Remember, that means they add up to 180 degrees. Let's get a refresher on the visuals here as we look at this example. If line AB is parallel to line CD, and again, we have the markings that proves that, then angle AEF, which is this angle here, plus angle CFE, which is this angle here, would be supplementary. Remember, that's consecutive interior angles. It's in between my parallel lines and on the same side of the transversal. Remember, supplementary means they have to add up to 180 degrees. Again, we have this same figure with that 123 degree angle. We have to find the angle that forms a consecutive interior pair with the 123 degrees and then find the measure of that angle. So my parallel lines are A and B. My angles in the interior would be the 123, the 6, the 3, and the 4. But remember, consecutive interior angles are on the same side of the transversal, so that would give me angle 4. It's on the same left side of the transversal as our 123. And these angles, again, we're learning today on parallel lines, are supplementary to each other. So that means the measure of angle 4 plus the 123 degrees equals 180 degrees. And that's just a simple subtraction property of equality for us to find the measure of angle 4 equaling 57 degrees in this example. Again, we must apply algebra to these angle theorems. So here we have parallel lines. I can recognize that. They have a matching amount of arrows on them. I have an angle pair. I have to recognize these are in the interior of my parallel lines, and they're both on the right side of the transversal. That makes them consecutive interior angles, and we're learning right now on parallel lines, consecutive interior angles are supplementary to each other. So that means that 2x plus 43 plus 2x minus 3 has to add up to 180 degrees. We're doing algebra from there. Got to combine like terms. First, 2x plus 2x here on the left side of the equal sign. They're on the same side, so I use the same sign. That gives me 4x's. I got a positive 43 and a minus 3. They're on the same side, so I use the same signs that they have. Positive 43 minus 3 gives me the plus 40. I get that 4x alone now by subtracting 40 from both sides. Gives me 4x equals 140, and then I can divide both sides by 4 here to get x equals 35 degrees. And again, we're just asked to solve for x, so that's our answer here. Then alternate exterior angles are congruent to each other. So this is a quick little recap here. The corresponding angles, the alternate interior angles, and the alternate exterior angles are all going to be congruent angles on parallel lines. The consecutive interior angles, that's the pair that's different. Those are supplementary to each other. We must memorize all of these theorems. As we look at our visuals here, again, we have line AB being parallel to line CD, because they have a matching amount of arrows. Angle AER, which is this angle right here, it's exterior, it's outside of my parallel lines, would be alternate exterior to angle SFD, which is this one. Remember, alternate exteriors, you go to the opposite side of the transversal and then to the opposite line. So these are here, and again, on parallel lines, these alternate exterior angles are congruent to each other. In our figure here, we're going to identify the angle that is alternate exterior to angle 1, and then we're going to find the measure of that angle if angle 1 is 108 degrees. So angle 1 is up here. The alternate exterior angle would be on the other side of the transversal and on the opposite intersection, which would be angle 8. And because we can see here that lines L and M are parallel to each other with matching amount of arrows, that means these angles have to be congruent to each other. Again, one more time to stress the importance. If we didn't know these were parallel, it would be impossible for us to find the measure here of angle 8. But because the lines are parallel, we're learning here that alternate exterior angles are congruent on these parallel lines. They have to be equal in measure, so that means the measure of angle 8 must also be 108 degrees. Applying our algebra now, we can recognize these are alternate exterior angles where our y's are because they're outside of our lines on opposite sides of the transversal. We recognize that these lines are parallel because they have a matching amount of arrows, and then we are drawing on our memory here that on parallel lines, alternate exterior angles are congruent to each other. So that means those values must be equal. That 3y plus 53 must equal that 7y minus 55. From there, we're doing algebra to get y by itself, following all of our same usual steps. We want the variables on one side of the equal sign. I like to move the smallest, so I'm going to be subtracting 3y from both sides. Leaves me 53 on the left equal to 4y minus 55 on the right. Now I can get 4y alone by adding 55 to both sides. That gives me 4y equals 108. Then I can divide both sides by 4 to get y equals, should be 27 in this example. And it's only asking me to solve for y, so that's my answer here. We often see that students don't tend to struggle when we're given just single angle pairs on parallel lines and we have to solve for variables. The ones that are going to be the most challenging, the scenarios that are going to be most challenging, is when we have multiple angle pairs involved or multiple variables to solve for on parallel lines, and we will have that. It's going to be a common thing that we have to solve in this unit. In our first example here, we have an x and a y to solve for, and our directions tell us that line M is parallel to line N. Again, we beat the dead horse here. If we don't know they're parallel, it's not possible for us to solve. But because they're parallel, all these theorems that we're learning apply here. So again, we're just trying to find one angle pair at a time and solve for one variable at a time. I can't solve for x and y simultaneously. What I can notice though is that my x is up here at the top right of its intersection, and this x is at the top right of its intersection as well. Those are matching positions. That means these are corresponding angles, and on our parallel lines, these corresponding angles must be congruent to each other. Therefore, that 5x minus 6 will equal the 4x plus 6. And I can start here and solve for x. Getting all my x's to the same side, I would subtract 4x from both sides. That would give me x minus 6 equals positive 6. Then I can get x alone by adding 6 to both sides. That gives me x equals 12. Now some people struggle from here. Once you solve for one variable, how do I get to the next one? Well, what I need to do with a variable now is find out more information with it by substituting or plugging it into the angles that already contained x. Okay, and hopefully what you guys can notice is that where our y is, that angle is actually vertical to my 5x minus 6. So once I plug x into this angle, I'll know that y has to equal the same amount of degrees because these are vertical angles. So I'm going to plug my x into 5x minus 6. So 5 times x, which is 12, minus 6. 5 times 12 is 60. 60 minus 6 is 54 degrees. Therefore, in this figure, we know this angle is 54 degrees. That is vertical to y, so y must also be 54 degrees. X is 12, y is 54. Examples like this one are going to be a little tricky because there's only one variable involved, but the angles that have been given to us are not one of these angle pairs that we've been learning about here in our last few sections. So you could argue that you could make up a name for this being consecutive exterior angles because they're both on the same side of the transversal, but they're outside the parallel lines. But instead of coming up with our own name and own relationship that I haven't provided you a theorem for, we are going to use the angle pairs that we already know exist. For example, I know that that angle 3x and this angle that's right next to my 4x plus 19, those are alternate exterior angles. And because we're told here that our lines are parallel, I know these angles have to be congruent to each other. So what we can do that can help us in these scenarios is I know that these angles are the same. So I can also call this 3x. It's going to be the same exact value. And now I can draw upon other angle pairs that I've learned about that would apply for these two angles. Hopefully you recognize here these are a linear pair. They're side by side on a straight line, a straight angle. They're supplementary. They have to add up to 180 degrees. Therefore, 3x plus 4x plus 19 is going to add up to 180 degrees. Combining like terms needs to happen here in this example. I got 3x plus 3x. They're on the same side, so I'm using the same signs that they have. 3x plus 4x gives me 7x's. Got plus 19 equal to 180. To get that 7x alone, I'm going to subtract both sides by 19. That'll give me 7x equals 161. Then we're going to divide both sides here by 7 to get our value for x, which should be 23. Double check that real quick. Yep, x is 23 in our example here. All right, I got a fun example here. I have lines that are parallel because they have the same amount of arrows that are on them. And we see I have this like triangle in between the lines, which if we know about triangles and the properties of triangles, this could definitely help us to solve for the 4 variables that are in this problem. However, we're going to draw upon our angle pairs that we've learned about in order to solve this. Instead of thinking of this as a triangle, we're thinking that there's like 2 transversals that are coming through our parallel lines here. There's one there that I highlighted in green. There's this other one here that I highlighted in red. And individually with these transversals, we have angle pairs where we can find the measures of some angles. For example, with the red lines that I've highlighted here, if I were to draw those separate from each other, that 55 and A, hopefully you can tell, are alternate interior angles, which are always congruent to each other on parallel lines. So if I can visually recognize that, then I know that A is 55 degrees without having to do any math. From there, we can move on to a different angle. Like I'm gonna go on to C right now, which I can do with a linear pair. As a matter of fact, I changed my mind. I'm gonna show you something better here because we have this angle relationship now. Looking at my green lines in this transversal, where the B and the 123 are, those are consecutive interior angles, which are supplementary. The same would happen here with 123 and C. Those are a linear pair that would also be supplementary, but I'm using our angle pairs here to solve this. So those have to add up to 180 degrees. If I subtract that 23 from both sides, I'm gonna get 57 degrees for B. And then now looking at the same lines where the B and the C are, again, if I draw those separate, those are alternate interior angles. And on parallel lines, we've learned that those are congruent to each other. You see the theme here. I'm just using one angle pair at a time to try to find angles. The last one requires some of our previous knowledge there to solve for D at the top of our triangle. We should know on any straight line needs to be a total of 180 degrees. Those 3 angles up there are all on one side of that straight angle, that 180, therefore they have to add up to 180 degrees. So D is my only unknown variable left. I already found out that B is 57, and when I add all of those together, they all have to add up to 180 degrees. That 57 and 55 are going to combine to give me 112, and when I subtract that 112 from both sides, I'm going to get 68 degrees for D. So A is 55 because it was alternate interior angles with the 55. B is 57 because it was consecutive interior with the 123. C is 57 because it's alternate interior with the 57 from B. And then D is 68 because 57 plus angle D plus 55 degrees all have to give me that 180 on that straight line. Great example here. We're going to wrap up our lesson today by talking very briefly about converse theorems. Which converse theorems, if you remember from our Unit 2, our conditional statements, a converse is when we switch the hypothesis and the conclusion of a statement, when we exchange them. So it's going to kind of be like working in reverse from these theorems that we've been learning. So all the theorems here in 3.2 have said, if lines are parallel, then our angle pairs are congruent or supplementary to each other. And so just the converse of that is also going to be true. If we have angles that end up being congruent and they're corresponding angles, then that means the lines that they're on must be parallel to each other. So we're just going to use that to answer some questions that are worded a little bit differently, and we'll also see this on some proofs in the future, right? So again, that's exactly what this says here in this block. So we learned in our theorems, if parallel lines are intersected by a transversal using corresponding angles here, then corresponding angles have to be congruent. The converse of that would be, if corresponding angles are congruent, then the lines that they're on must be parallel to each other. So the logic that's involved there would help us answer a question that's worded like this. In our figure, it doesn't show that these lines are parallel, but it's asking me to solve for x so that the lines are parallel, meaning that all of our theorems that we learned only apply on parallel lines, so we're just using those with the angle pairs that are given to us, okay? I can only solve for x if my lines are parallel by identifying the angle pair and then using the appropriate math that belongs there. So if line L is parallel to line M, certain math would happen here. These angles would be consecutive interior angles. They're in between L and M. They're on the same side of the transversal. They're consecutive interior angles. And on parallel lines, consecutive interior angles must be supplementary to each other. Therefore, that 12x minus 8 plus the 104 would have to equal 180. So the value I get for x in this equation would make line L parallel to line M for that math to support my converse theorem for parallel lines, right? Combining like terms here, I got negative 8 plus 104, so that gives me 12x plus 96 equals 180. I can subtract that 96 from both sides to get 12x equals 84. Then I can divide both sides by 12 here to get x equals 7. If x is 7, that makes these consecutive interior angles here supplementary. It makes them have to add up to 180, and because they add up to 180, that makes these lines parallel, because those angles only add up to 180 on parallel lines. In our last example, again, we're going to solve for a variable so that my lines are parallel. Again, it just means for the angle pairs that I'm given here, I'm treating them as if the lines are parallel to get the right value for x. This example, though, I don't have a direct relationship between this is a 45 down here and a 5x plus 35. I know it's a little blurry. So I'm going to use angle pairs that I am aware of to place a 45 in a different location. What I'm going to do is I'm going to use corresponding angles. So that 45 is in the bottom left of its intersection. Angle 3 is also in the bottom left of its intersection. Those angles have to be congruent to each other. Therefore, angle 3 here must also be 45 degrees. Now I can, and again, that's assuming that my lines are parallel to each other, right? On parallel lines, these would be congruent. So now I can solve for x using this linear pair right here. Underneath this straight line, I have 45 degrees and 5x plus 35. Those have to add up to 180 degrees. So 5x plus 35 plus 45 equals 180. Combining like terms here, 35 plus 45 gives me 80. I can subtract that 180 from both sides of the equal sign to get 5x equals 100. And then I can divide both sides by 5 to get x equals 20. So x being 20 allows for this angle to be 45, which means that these angles are congruent as corresponding angles. That makes these lines parallel to each other. I know the logic seems a little weird there as I explain it, but essentially we're just using our theorems that apply for parallel lines to solve for variables here. We'll see how this kind of changes a little bit in our thinking and our reasoning as we do geometry proofs that require our converse theorems. It's a little bit later on in Unit 3. This wraps up section 3.2. Remember, this is all about our angle pairs on parallel lines. Please don't forget, all the stuff we learned today only applies when parallel lines are intersected by a transversal. Again, that wraps it up. I'll see you on the next lesson, guys. Bye.